Ciao a tutti, sono qui
Ciao.
con Angel. Benvenuti al primo meetup dell'anno del Kubernetes Cloud-Native Milano Meetup. Sono Diego Braga e all'interno di Kiratech ricopro il ruolo di Solution Architect e ho l'opportunità e la fortuna di essere l'host del meetup di oggi. E abbiamo qui con noi Angel Barrera, che si presenterà. E l'obiettivo di questo meetup di oggi è presentarvi il talk di Angel, che sarà sulla resilienza di Kubernetes, e Angel proverà a stressarlo parecchio e ci farà una prima introduzione del concetto della resilienza di Kubernetes, e poi ci sarà anche una demo in cui ci mostrerà cosa si può fare, cosa succede a fronte di alcune operazioni di stress sul cluster. E il talk sarà in inglese, quindi se volete lasciare dei commenti alla chat vi chiedo cortesemente di lasciarli in inglese, poiché così possiamo anche mostrarli ad Angel, altrimenti farò il traduttore al meglio che posso. Quindi benvenuto Angel, let's switch to English.
Yeah, grazie.
And welcome on stage, and you can start with your demo.
Okay, perfect. Let me know when you see my screen.
I can see it.
Okay, so let's start. First of all, thank you for inviting me to the Kubernetes and Cloud-Native Milano. It's a pleasure being here talking to you. Sorry for my, to switch to English. Also, my English is not the best, but I think it's going to be enough. Today I want to talk about some kind of controversial topic, which is running Kubernetes with just a single master. This is supposed to be a talk not for, to giving you all the information about how to run it or what is the best solution and so on. It's about making you think about another possible solution for your stack or your business or your startup. First of all, I want to clarify that I'm not the master for sure, nor single, that's the joke. My name is Angel Barrera, as the organizer said. I'm currently working at SIGHUP as Kubernetes engineer. What it does mean is that I'm responsible of the Fury distribution, among other open source projects that we have. And in my past, as you can see, I started my journey as a full stack developer, something like that, pushing code to multiple Kubernetes cluster, also OpenShift clusters, writing applications in Java, in Python, and some of them in Golang. Then in 2018, I switched the role of developer to from developer to like a platform engineer, an architect, I don't know, infrastructure guy, a DevOps team. I don't know how to name it properly, but I was in charge of creating clusters, updating them, also teaching other developers to deploy their application to different clusters and so on. So it was funny during 2 years. And then along with a friend of mine, which is Paul Rosselló, which is working at Giant Swarm currently, we started a project which is Cloud. It was a SaaS service offering Kubernetes namespaces as a service, and now it turns into an open source project available in GitHub. It's fully open source. You can take a look and play with it. And finally, later that year, I started working on SIGHUP. Again, with this amount of experience, it's like 4 years more or less, or 5 years working with Kubernetes. I cannot consider myself as an expert or master. Why? Because, Kubernetes releases a new version every 3 months, more or less. And it makes super difficult to be aligned with the changes. And also, if you want to run Kubernetes in production and Kubernetes as a platform, you need to deploy other software. And if you look for software in the CNCF, you can see a lot of projects out there. all the projects has its own release cycle, and it's really, really, really difficult to be an expert in Kubernetes and the CNCF. So I'm not the master. I will say something wrong for sure in this talk, but don't take care about that. Just listen and enjoy. For today's agenda, the talk will cover these few points. We are going to see a common use case that we face sometimes, which is someone who wants to improve their platform. Also, we are going to discover how it's supposed to be deployed a Kubernetes cluster in production, and the single master alternative. If everything goes as expected, I will perform a demo in which I will destroy the control plane in a single master Kubernetes cluster. And finally, we are going through the recommendation, advices, consideration, and some conclusions about this topic. So this is Alice. Alice is the CEO, the CTO, or any responsible person in a startup. She's running a cryptocurrency tracker app. Imagine another business, but in the end it's the same. That it currently runs on containers, maybe in virtual machines in the cloud, and so on. So I'm almost sure that you face this kind of environment very often. The Alice architecture diagram looks like this one, more or less, which is like 3 VMs in the left of the screen, and a DNS or a load balancer in front of the VMs. And the application is properly working. But Alice is facing some issues when the team needs to automate the deployments of new releases, and when the team wanted to deploy like a new version for a subset of customers, they are facing some issues and they don't know how to do it, and so on. So also they face problems or issues to monitor or proper monitor the instances and the application at the same time and correlate the metrics. And another interesting topic here is they wanted to have replicated environments to maybe debug an issue, or maybe develop a new feature or something like that. And it's really difficult if you don't have a proper way to replicate your environment in an isolated environment. So someone in the team or someone discover Kubernetes and suggest Alice to take a look to Kubernetes, because Kubernetes out of the box provides some of these features to your application. So the first thing that Alice or anyone in the team needs to do is to do a Google search and look for information about how to set up a Kubernetes cluster in a production way. So Alice or anyone, it doesn't matter, found this link. You can see the source in the bottom of your screen. If you want to deploy a Kubernetes cluster in high availability, you need to deploy at least 3 control plane nodes, and the control plane contains like 3 main components, which is the API server, the controller manager, and the scheduler. These 3 components are part of the Kubernetes binaries. And also you need to have an etcd member or server. The etcd is the database which stores the state of the cluster. etcd is just a key value database, a distributed key value database. So you will need like a cluster of etcd plus the cluster of the control planes, of the Kubernetes control planes. And in front of the control plane nodes, you will find the load balancer, which is requested by the worker nodes. So now, if you remember the previous slide where you saw the current Alice setup, it was like 3 nodes or maybe 4, and now Alice will require the 3 nodes that runs the application in the worker nodes, plus a load balancer, plus 3 new nodes. it zooms like 7 nodes more or less. But if you follow finding for information or looking for information on internet or in the official documentation, you will find this new diagram, which externalizes the etcd cluster in a separate nodes, adding like 3 more nodes to the equation, and it makes like 10 nodes more or less instead of 3. If you follow looking for information about how to make it production grade, you will find this kind of sentences around internet, like saying like the master node should be provisioned in odd number with at least 5-member etcd cluster in production. So it adds another two new instances to the equation. Also myself, when I was a consultant deploying cluster to my clients and so on, I didn't imagine another way to do that other than deploy everything in high availability. So the etcd cluster separate from the control plane and then the worker nodes. So it is kind of difficult. You can see the girl face. It's really difficult, to set up a Kubernetes to host a production application. So this is why I end up with this approach, which is the single master. This is like the default setup that you will end up if you run kubeadm. kubeadm is the basic or the most used Kubernetes installer out there. It's maintained by the Kubernetes community, and what it provides is an easy way to install a control plane and then to join nodes. So first, you need to deploy a control plane node. You can see in the top right corner, you can see the master node here, and then you will deploy worker nodes in maybe an auto-scaling group or something like that, pointing to the control plane node. You can see here that the database is in the same control plane node. So you don't need to have a cluster of etcd. You don't have to need a load balancer in front of the control plane nodes because you only have one instance in the control plane. Another alternative that I really like is using Kind as a proxy of the etcd. Let me explain this a little bit because it is kind of confusing. This is exactly the same setup as the previous one, but with a key difference, which is having an external database. In this case, it's an SQL database, and a Kind proxy deploying the same control plane node. The Kind proxy is a project from Rancher, which is also used by K3S, a super famous distribution from Rancher. And what Kind does is to translate etcd queries into SQL ones. And what Kind enables is to be benefit of some cloud providers that provide you cloud managed SQL databases like RDS in AWS or Cloud SQL in Google Cloud, where you can deploy a database with just a couple of clicks and then automate the day-to operations like backup, the resize of the instance, the escalation of the instance. If you need another replica and so on, it's really easy to manage. Instead, if you try to do the same with etcd, it's quite difficult to scale an etcd cluster and so on. So what Kind does is to translate etcd into SQL dialog. So it's time to run the demo. I hope it will be better than the Tesla, the cyber track the last year or 2 years ago. I don't remember. So today's demo, let me zoom a little bit. Today's demo is about a cluster like the one I showed you before, which has a master node here and 2 worker nodes. And also we have an application running for sure in high availability with 5 replicas and a backend or a Redis cluster acting as a backend, as a database. And yeah, it is working. It is working here. You can see here. You can see the application here is pretty simple. It's just a guestbook application. It's like a demo application out there. You can see it here working. If I type here like hello Milano, 0, you can see that the message appears here, but also here. Okay, so the application is working. If I refresh the page, everything continues there. And yeah, it's a super simple application, a PHP application. So what will happen if I destroy the master node? This is what we want to discover, no? So what we want to discover is what will happen if I destroy this instance. So let me go to my cloud provider, which is currently AWS. Let me filter for this instance, and then let's see if I can terminate the instance and say, bye-bye, master node. Okay. So this is the master node. I'm currently inside the master node. Currently it's working. It takes like 10 seconds to spin down the master node. And what you will see in upcoming minutes or seconds is that the application here is going to start failing some requests. Okay, so if you look the click, I am refreshing the page, and you can start here seeing some failures. Okay, and some of the request works. Why this is happening? This is happening because we are shutting down the control plane. You can see here that the control plane was shut down by the AWS. And we are shutting down the control plane, which hosts the API server. Okay, the API server is one core component of a Kubernetes cluster for sure, because some of the internal components of Kubernetes talk with the API server, like for example the core DNS, like for example some CNIs, Proxy. There are some components talking with the API server. So we don't have more replicas of the API server. So some components start to fail, like the Proxy or core DNS. And in some point, these components, like Proxy and so on, realize that the API server is not going to be, is not running, and they freeze its state. I mean, Proxy is the one involved in creating and modifying IP tables in a node. Kubelet does the same with containers. The CNI does the same with Proxy. So when these components detects that the API server is down, its state is freezing, and this is why if I refresh the page, now everything works because the state of the cluster is completely freezing. Also, you can say, okay, Angel, but what if you add some messages here? So I can type like, hello, are you live? And you can see here at the backend that the messages are here, so everything works. And this is what we wanted to demonstrate, which is what happens if my control plane node goes down while my worker nodes that host the application are already up and running. So the answer is the application continues working. You can expect some failures that, like I demonstrated before, but after a couple of minutes, everything is going to be stable again. So the demo went well. Let's continue. Okay, so let's start with the consideration and so on. First of all, you have to back up everything as much as possible. You can perform backup policy with machine snapshot. You can perform backups of the PKI of the Kubernetes cluster and also the etcd cluster if you have it. And for sure, backup the etcd database and also the manifest, everything you want as much as you can. And yeah, it's really important what I wrote in the bottom right in your screen, which is don't forget to test your recovery strategy, because otherwise you don't have a proper working backup. So please, if you take backups of your infrastructure, then test in a recovery scenario. And this is for me, is something super personal, but this is for me like the key of this presentation, which is avoid not only etcd operations, but avoid additional complexity in your platform, because Kubernetes is complex. I mean, as I said before, Kubernetes changes every 3 months. The CNCF project changed a lot, so it's really difficult to maintain your Kubernetes cluster alive and working and updated. So if you can avoid etcd operations, because etcd is a complex database, it's not complex, but the day 2 operations are kind of complex. So it has its own clustering rules, and you have to take care about brain splitting and so on. So it's kind of critical for a Kubernetes cluster. So try to avoid this kind of operations. And this can sound obvious, or yeah, it can sound obvious, but ensure that your application runs in high availability, using not only the replica number in your stateful set or in your deployment, but also using the objects of that Kubernetes provides you, like the pod anti-affinity, the pod destruction budget, using the right node selector, the anti-affinity, and so on. So ensure that your application is spread across multiple nodes, across multiple availability zones, across multiple data centers. It doesn't matter, but ensure that your application is running in high availability. And also, I want to mention that if you Dockerize your monolith, it will not be high available by default. Just put in 2 replicas. So you have to be sure that your application is ready to run in high availability. For example, if you deploy, I don't know, maybe a WordPress application and you spin up multiple replicas, it will not serve WordPress in high availability, because you have to take into account the file system, you have to take into account the sessions and so on. So ensure that your application is running in high availability before going with a single master. And this is also pretty interesting, in my opinion, because when you deploy a KubeADM cluster, the first action that you need to do is to deploy the control plane node, which is the one hosting the API server, controller manager, kube proxy, and so on, but also the core DNS. And the core DNS by default is deployed with 2 or 3 replicas, I don't remember. But if you only have one control plane node, you will have the 2 or the 3 replicas in the same node, okay? Then if you deploy new worker nodes and you join the cluster, these nodes, if you don't say the core DNS to spread to all other nodes, the core DNS will remain in the master node. And if you run the demo that we did before, which is destroying the master node, you will end up with a cluster without DNS, and this is kind of difficult to run. And someone maybe is thinking about GitHubs, but what the hell is GitHubs? GitHubs is just super quick. GitHubs is a new paradigm, a new way to deploy application in Kubernetes or in other platforms for sure. But we are now talking about Kubernetes, in which your application repository splits in at least 2 repositories, one with the code and the other one with the deployment information. The one with the code will run a pipeline as usual, in which you will build, test, and deploy your application into a registry. And then someone will PR the configuration repository, changing the version that you recently created. And instead of pushing you directly the new deployment into the cluster, is the cluster that pulls the information from that repository. Why I mentioned the GitOps paradigm? Because someone can think about, do I need to really back up my manifest or back up the etcd if I follow or if I am running a GitOps approach? This is like an open question that I really like to ask you. Do you really need it or not? It's up to you. I saw in Twitter and in other forums that there are people running ephemeral Kubernetes cluster with the GitOps approach, and not only and they are not using only GitOps for the application layer, but also for the Kubernetes stack, like deploying the right daemon set to run the log recollector and so on. So it's kind of a new paradigm that may have a new test, in a new chance. And yeah, few considerations here. If you are running master maintenance like updating Kubernetes, or your cloud provider stopped your instance because something is happening in the physical host, or something happens in your VM, you will not be able to deploy changes for your applications because the API server is down. And maybe more interesting is that your application is not going to be rescheduled, meaning that if a node goes down, all the replicas in that node are not going to be relocated to another node because the scheduler is not up and running and so on. So take in mind that during a control plane maintenance, you cannot do that. But the key questions here is, can I plan this kind of interactions like Kubernetes updates or host maintenance? Or how long does it take to run this kind of maintenance? And the key question here is the one involved, is my business impaired if the master goes down? And can I work to avoid it? And this is related to the demo. It's like you have to analyze if all your components runs even if your master or your control plane goes down. Because we found while researching to do this talk that some CNIs, at least with the default configuration, doesn't work if the API server of the control plane is down. For example, Calico, if you don't deploy the Tifa component, which is an add-on that interacts with the API server acting as a middleware or something like that, if you deploy Calico with the default configuration, if the control plane goes down, you will face some networking issues. It's going to work, but in some cases it is not, because it depends on the node that you request. So it's different that, for example, Flannel that is used that I use in this demo. I use in this demo Flannel, and it is more reliable in these scenarios than Calico, for example. Mention that this is the default setup of Flannel and the default setup of Calico. So for sure, Calico can be configured to be reliable using Tifa, for example. But this is not the last. I mean, you have to think about where will be located your cluster. It is not the same running Kubernetes in cloud than in on-premises in your own hardware, because you have to think about almost all the cloud providers provide more than one region or availability zone or data center where you can place your control plane nodes, and then have to have a proper high availability control plane. And also, if you are running on cloud and maybe in some on-premises, you can run snapshots that makes easier to manage the backups. And some other cloud providers provide you a managed service that ensures that you will have a control plane up and running with a 99.999% percentage of availability. So it's you have to consider these two options, or you have to think about where will be located your cluster. And the question or open question for you, for the audience, is if you deploy your cluster in, for example, AWS, do you know how much is the cost of the networking traffic flowing from an availability from one to another? It's around 1 cent per gigabyte. And you have to think that the etcd is as I mentioned, the etcd is a distributed database which is replicating data constantly, and you can end up with a huge bill in your monthly invoice and in your cloud provider. So take care about that while deciding where to locate your cluster. Also, we are not sure, or we cannot be sure about how many nodes are behind a managed service in the cloud. Yeah, for sure in Google Cloud, you can select if you need a regional cluster or a zonal cluster. And it means like, okay, I just need one node or multiple nodes. But in other cloud providers like ETS or from Amazon or from Microsoft Azure, you don't know. So you don't know how they are managing the control planes. And for sure, you have to know how you want to perform the backups, because it's really important to know how you are running your backups actually. And also, it's interesting about what will host your Kubernetes cluster, because if there is a single application like the Alice demo that we ran before, it could mean that they are going to be not a lot of deployments or bug fixes or deploy new features and so on. And it could mean that it's going to be managed by a full stack developer team. That's not the best scenario, but you can face it. And in the other side, if your Kubernetes cluster hosts multiple applications, it could mean that there are more and more deployments or more interaction with the API server. And it could mean that the cluster is managed by an operation team, which is more professional, let's say, more capable of managing them. And if you are facing like your cluster is going to serve platform services for your organization, it could mean that the cluster is going to be more like frizzy or stateful, and it's going to be managed by an operation team. So open question for you is, how often are you going to interact with the API server? How often are you going to deploy changes for your applications and so on? Is your business impaired or affected if you cannot deploy changes for 2 hours, 4 hours, or any number of hours? And again, is your application ready to be configured in HA? Yeah, it's something to consider. And again, who is going to manage the cluster? A dedicated team with enough experience, with enough people, and so on, or maybe the cluster is going to be managed by developers, so with following a DevOps culture. And how many people can dedicate enough time to the cluster? And yeah, and what about security? Does the developer has previous experience managing these kind of clusters? An open question for you is, will I be able to manage this kind of cluster by my own, or am I ready for it? Should I hire someone? Should I use managed services? It depends on the scenario. You have to choose one option or another. Again, it's if you remember the number of nodes that you need to run Kubernetes in high availability, it was around 10 or 12 nodes. So the budget here is important if you are running a startup. And for sure, it's not really important if you are running in a big company with such with a big budget or near an unlimited budget. So it's really different depending on your budget. So questions for you: do I need dedicated people to host and manage the cluster? And yeah, how much I need to pay to hire a Kubernetes administrator? It's something that is really difficult these days because there are not a lot, and all of them are working in the industry. And yeah, maybe the most important question is the third one, which is, do I really need Kubernetes? Because maybe in the use case, the Alice use case, maybe she doesn't need a Kubernetes cluster, because if the business is running and the business is, profitable, yeah. If the business is going well, why I need to change the infrastructure to make it more and more complex if I don't have enough budget, or if I don't have enough people, or if I cannot find the right people to run it? So it's, yeah, again, you have to think about if you need it or not. And for sure, can I pay for professional services from a Kubernetes certified provider, like, for example, SIGHUP or any other listed in the CNCF landscape? And finally, yeah, I will stop talking after this. Conclusions. Running Kubernetes in production is really, really difficult and complex. You have to think about a lot of moving pieces. The second statement is, for me, the key. Try to avoid additional complexity, because Kubernetes is complex itself. You have to know your environment. You have to know your team, your budget, and the business behind or you are supporting. You have to back up and test your disaster recovery, for sure. And finally, the last sentence is, yes, your apps will still be running even if your control plane goes down for a limited time, maybe. But yeah, your application is going to be there even if your control plane goes down. Thank you so much. I hope you enjoyed the talk. I left here my contact information. I'm available in Slack, in the Kubernetes official Slack channel. Also, I'm really, I post the GitHub, my GitHub repository with the configuration of the cluster, that then you can take a look to how I spin the cluster. And yeah, I'm open to answer your question if any.
Thank you so much, Angel, for your great talk. We have a couple of questions. Fabrizio wrote down in the chat, so I can share them. And actually, the last question is the same, the one that I was going to ask you. So I will give all the visibility to Fabrizio in order to make this question. But the first one is this one. So using data store different at TCD is not supported or recommended by the Kubernetes maintainers. Is using kind of risk? Does the risk compensate the advantages?
Okay, so yeah, for sure it's not something supported by the community. It's not in the Kubernetes upstream project. It's something that Rancher is using actively. So yeah, maybe it depends on your business. As you said, as you saw in my presentation, it depends a lot of if you are running on cloud or on premises, if you are a big company, if you are running a Kubernetes cluster per application. It depends a lot in your environment. In my opinion, I saw Darren, the CEO of Rancher, running K3s with a lot of workers with a lot of replicas using Kind. So in my opinion, the 99 or not 99, okay, the 90% of the use cases will work without any risk, and could be some scenarios where a kind is not going to be enough or is not the best solution. But for me, it's like the perfect choice if you are running a small to medium cluster in the cloud. That's my opinion. And also, for sure, if you are not using a managed service like EKS or GKE, something like that.
Yeah, I do remember that when Rancher donated the K3S to the CNCF, there were some arguing about the kind, the bottom instead of a TCD, because it would look like a fork from the upstream project. So, but still, yeah, this is a great answer. Thank you. The other question is still from Fabrizio. So we're recovering from a control plane busted in a single control plane cluster. The problem I faced is the control plane endpoint being changed. What do you think about always using a DNS name for the control plane endpoint?
Yes, this is some consideration that you have to take in mind. What I used to do is, even running on cloud, I used to set static IPs instead of DNS, because also if you have DNS, you can face some issues because of the cache, of the worker nodes, and so on. So I prefer to fix or to stick some private IP on the master nodes, and then use that IPs instead of a DNS. But yeah, I have a demo. I have an extended demo of the one I showed before, that destroy the control plane and then recover the control plane with an AMI snapshot with a persistent private IP, and it works pretty well. You have to restart the kube proxy in some workers, if I remember correctly, but you can recover. The main answer here is that you can recover even if your single master control plane goes down.
Okay, so you already answered the next question. I will show it anyway, but the last question from Fabrizio was, it will be great to have a follow-up on this talk showing how to recover from this situation. And it was exactly the question I was looking to make to you, because how can I recover from this fault as you have shown previously?
If you go to my repository, the one I showed before, there is some guidelines to recover, so you can follow the README and recover if you follow the instruction, the guide I wrote there. So it's already documented how to perform the demo, so you can do it anytime.
Okay, we have one question from TotoJack77. If you have other 12 hours, we will have time to answer, because the question is, do I really need Kubernetes? So when do I really need Kubernetes? So we can spend a week talking about this, but if you want to give us your opinion about that.
It's really difficult, also because I'm working in a Kubernetes oriented company. So my answer should be like, you always need Kubernetes, but reality is different. When you have to orchestrate multiple microservices, multiple applications, it could make sense, but you have to be ready to run Kubernetes. I mean, you have to ensure that you have the right people, or you have the right budget to hire someone, or you will pay for professional services from a company like SIGHUP or like any other one in the CNCF. So yeah, you have to be ready. If you are not ready, and you have to be honest with yourself, I am ready to run Kubernetes. If you say I don't know, maybe not. Maybe you don't need Kubernetes.
Okay, we don't have any more questions. Thank you so much, Angel, for the great talk, and thank you for all the people that watch this live meetup. And I can switch to Italian, and vi ringrazio per aver partecipato al meetup, e vi ricordo che tra un mese ci sarà il nuovo meetup in cui il sottoscritto con un collega parlerà di Istio come strumento per federare cluster Kubernetes tra di loro, e sarà un talk in italiano, quindi vi aspettiamo numerosi anche al prossimo evento. Se avete delle domande da porci, anche ci potete trovare anche sulla pagina del Meetup. Vi ringrazio e vi auguro buona serata. Thank you, Angel. Thank you, everyone,
Grazie a
and
te.
have a nice evening.